So, I don't think you have these written down. Nobody does. These free responses? These two right here? Yeah, nobody does. I say nobody. There are online. They're under the blank notes. But, anyways, I didn't print them out because I wasn't going to give them to you for homework. So we can just look at this and do this together. You don't have to write it all down. You can if you want to. You can take a picture of it if you want to do that, or if you want to just get it when I post the notes. That's fine too. There we go. Okay, so the table below shows function values and graphical properties for a cubic polynomial function, h of x. And so it gives us some information. So A, at what x value or values does the graph of h of x reach a relative maximum? Now define for me, how did we find a relative maximum? It went from something to something else.
A relative maximum went from the...
We know what it looks like, right? It looks like that. So on this side, it's increasing, it's going up. And then on this side, it would be decreasing. So that's basically the definition of a relative maximum. It's the point at which it changes from increasing to decreasing. And then the minimum would be the opposite. It would be the point from where it changes from decreasing to increasing, and then justify our answers. So we can see, where is it changing? At what point does it change from increasing to decreasing, or what x value? No, it's going to be 1 point. Because a maximum is not a range. A maximum is just the top of something. So when it changes from going up to going down, or increasing to decreasing, then that means that point at where it does that is where it's changing. So like here it's increasing, and here it's decreasing. So that means right here is where it's changing, because it ends increasing at -3 and it begins decreasing at -3. So that's right where it's changing. Does everybody see that? Seriously? Okay. So you would say x equals -3 is a relative max. Justify your answer, because h of x is increasing on -infinity to -3 and decreasing on -3 to -1. All right, now where would the relative min be, or relative mins? Say that again?
1.
Yes, because it's going from decreasing to increasing, decreasing to increasing. So right when it changes, that's going to be a relative minimum. So x equals -1. Oh, it says 1. Oh, that's the y value. Okay, I'm sorry. It's 1. Yeah, x equals +1 is a relative min, because h of x is decreasing from -1 to 1 and increasing from 1 to infinity. So that's what a max and a min is. And we only had to find the x value. Now, if we wanted us to find the actual point, we could do that too because it actually gave us the x and the y value. That was nice. I don't usually give you that much. B, is either of the two relative extrema, so that's maxes and mins, that you mentioned in part A, an absolute extremum, which is an absolute max or min, and justify our answer? Well, why?
Because the infinities that keep going.
Yes. Yes. And because it's cubic. If it's cubic, like she said, those infinities, they keep going, and they're going in opposite directions, right? So it's going to point up forever, and it's going to point down forever. So you cannot have an absolute maximum or minimum. So, no, because I'm going to say h of x is a cubic function, so it, no, I shouldn't say it, so h of x goes up forever and down forever. It's not real pretty sounding, but it works. And you know what I'm talking about, so that's more important. Now, points of inflection. So at what x value or values does the graph of h of x have a point of inflection justify your answer?
Is it -1 because it keeps decreasing?
Good point. Let's see here. So we have from -3 to -1. And then it goes, well, that doesn't mean it's a 0. Good point.
Teachers, excuse the interruption. Ms. Klein's third period should be reporting back to class at this time.
Isn't this, oh yeah, okay, I see what she's saying. I got it now. So, no, this one would not work because we don't know that it's a 0. If it was a 0, then yes, definitely. But we do know that 3 was a relative max, -3, was a relative max. And we know that +1 was a relative min. And one of our rules for points of inflection was halfway between those two. So that's what we're going to do. Halfway between those two. So those two are -3, 3. That was our relative max. And our relative min was 1, -1. So our midpoint would be -3 plus 1 over 2. And 3 plus -1 over 2. So -2 over 2, so that's -1. And +2 over 2, that's 1, is a point of inflection. And our justification of our answer is the work, and I guess I could say midpoint of relative max and min. And now we're going to sketch a possible graph. All right. So I have the point -3, 3. I have the point 1, -1. Those are maxes and mins. At -1, 1, that's where it's going to change concavity. I know it's concave down to begin with. So it's concave down. And then it starts going concave up. don't know where the zeros are because it didn't tell me. But I at least know where it's concave up and concave down, and I know that this point's supposed to be the lowest point and this point's supposed to be the highest point.
Teachers and students, pardon the interruption. Teachers and students, we are going to begin a series of drills at this time. The first drill will be a hard lockdown drill. You do not have to do anything at this time. Just listen. In the case of a hard lockdown, teachers are turning their lights off, lock your door, and move your students to a position in the room where they are not visible